Hi everyone, hope all of you are doing great. Welcome to today's video. In this video, I'm gonna discuss about the BGP attributes for the best path selections. Hope you have already gone through my previous video like BGP message and BGP states. Why I'm saying because after this BGP message and states, then only the attributes comes in picture, right? After establishing the neighborships, then only this chapter comes the BGP attribute for the best path selections. Like other routing protocol do we use for the best path selection like hop count, matrix, latency, all these stuffs. Similarly, BGP also use list of attributes to select the best path. All right. So here I'm gonna touch about the BGP tiebreaker for the best path selections. Also, I will show you how to rate the BGP table, right? Even I will show you the lab also over there. So it's very important for you. And this chapter even also itself a very important chapter, right? So let's get started, right? So we are here. We'll understand in this slide the BGP best path selections and tiebreaker and all the attributes, most of the used attribute, right? For the tiebreaker. So let me take you to the one analogy. That is, I hope everybody in our childhood we have played the football match, right? I am taking this analogy because it would be very easier for you to understand and it would be memorable for you, right? So what happened in our childhood in any football match, right? We mostly play two teams, right? So go to the conclusions to get the result, who is the winner, we has to or we have to go through multiple criteria, right? First, a referee do the toss part, right? Then one team elect to start the game. Then we play for the 90 minutes, right? Still, if it is result not come out, right? In that case, again it's tie. Then we have to go to another process, that is extra minute, right? We play for the extra minute, it could be 10 minutes or 20 minutes. Then we play for the golden minutes or golden hour, you can say. Still the result is not coming in, right? If again it is tie within the two teams, then we go to the penalty round, right? Again, if it is again tie, it's equal with the team, then we go to the toss round, right? So this is how we conclude our result, or we select the winner, right? The same way, BGP also follows multiple attributes to conclude or to select the best path, right? So this is how you can understand or enjoy your understanding, right? So before going to the BGP path selection attributes, the very fast attribute I will consider as it's very fast, that's what is 0, right? That is next hop, right? So what is next hop attribute? Suppose you have two different router and that router are in BGP neighborship, right? So fast criteria or fast attribute BGP to check whether his next hop is reachable or not. Then only it goes to check other attribute to select the best path, right? So we'll consider next hop is the very fast attribute as 0, and I will explain one by one, 1 2 3 4 5 like this way, all the attributes, right? Hope you understand. And this next hop attribute you can take analogy with the very fast, that is the toss round. Through that, one team elect to start the game, right? So the same thing over here. After checking the next hop, it checks the fast attribute, that is the wait attribute, right? This is the very fast attribute being checked in the path selection method or path selection mechanisms, right? So what is wait attribute? Let me tell you. The few points I have explained over here, all right? The very first point is you have to excuse me, very first point is the optional and transitive, right? So what is basically optional and transitive and optional non-transitive, right? A bit mistake I did. So it's a optional and non-transitive. You might think that what is optional and what is non-transitive, right? So let me take you to the attribute family. Yeah, so here it is. You have to understand this architecture or this attribute family. I always say here the BGP attribute is two type. One is well known, right? Another one is the optional. What is well known? Well known, the attribute, those attribute which is known by all the BGP capable devices, right? Whenever we configure with any peer, it could be any Linux device, it could be, right? In that case, it will be well known. Under the well known, there is two category: mandatory and discretionary. So what is mandatory? Mandatory must, because this attribute will must be there, right? And the discretionary is it's depend on decision whether it would be there or not, right? Something like that. And the optional is two type of optional. It could be transitive, it could be non-transitive. Now what is transitive and non-transitive? Let me tell you again. Just think there is two router again, right? Just try to understand with the diagram. It's not perfect diagram, still I'm trying to. So this is the BGP neighborship where you have configured one attribute, any attribute, right? So it goes to this router, travel with your update message, right? Now this router will not, or it's not transferred to the other router, so it means it's not transitive, right? If it is forwarded, in that case it will be transitive. This is how you can understand for now, right? So let me take you to the attribute, right? So let's understand one by one, right? We understand what is optional and non-transitive. Optional means it could be there or it could not be there. It's a purely optional, as it's the name, right? And here higher weight is preferable, and the range is 0 to 655,535, right? So whatever you configure the weight, if it is higher than other neighbor, that would be preferable over here. And another part you have to remember, try to remember all this terminology, because it is important for your any discussions or in your any interview, right? So the default weight is 32768 for whom, which is locally generated, right? And the default weight is 0 when the learn from other network. Now conclusion is that if you learn any route from other network, that would come with the 0 weight, right? And if it is weight locally generated, that weight would be 32768. Let me take you to the routing table in the BGP. Here let me explain what is this. Just a minute please. So here this is your weight column, all right? So once you run this command show IP BGP, here you will get one column where is weight is mentioned in Cisco router mostly, right? As it's a Cisco proprietary protocol. And if any, as I said, if any network originated locally, means it's configured this network within this router, which the next hop is 0. That weight would be 32768. Definitely that would be preferable. And the other network I have learned from different router or different AS, it could be that weight would be 00000, right? The same thing explained over there only, right? Just right here. Hope it is clear. Now let me take you to the next attribute. If the weight is checked, then it goes to next attribute, that is the local preference. Now what is local preference? Again, local preference is well known and discretionary. Now where is your local preference? Let me take you to the this address family, right? So where is your local preference? Here, right? Local preference, it's a well known and discretionary. The same thing it is also mentioned over here, right? Well known and discretionary, right? Another thing is mentioned over here, that is the it's local to AS. What do you mean by local to AS? Let me explain over here again. Suppose you have multiple router within one AS, it's mean it's a purely IBGP, right? So they are connected each other, right? And this is whole router comes under the IBGP, and this router connected to another router that is different AS, right? AS suppose 100, right? And this all router under the 200 AS, so it's IBGP universe, right? Here if you configure the local preference 200 in this router, it will transitive to other router, right? Other router, definitely all router can would be visible this local preference configured in this router. It will carry forward to the other router. But if it is crossover his own AS, in that case it will not be carried out, right? Hope you understand. Now what left? Use the manipulate outbound traffic. Hope you know well this part, right? Outbound traffic, suppose you are here, right? You want to reach internet. Here is your internet, and there is two path, right, to reach the internet, right? So you can use local preference to manipulate your outbound traffic in terms of data plane, right? Not control plane. But whenever you place the policy, or you configure the policy, or you manipulate the policy, that would be placed as a in. That is the control plane perspective, right? All right. Hope you understand. And the higher is preferable. By default, it is 0, right? Hope you understand. By default is 0, and higher is preferable. Or shall I take you to the table over here again? Right. This is the local preference table. Column, sorry. So over here you can see the default local preference is 0, 100, 100, 100, right? And why other option is blank, nothing is showing? Because all these route or all this network rather is learned via eBGP from other AS, right? Now you might think over here that how do you understand this route or this network I have learned from IBGP or eBGP? This is very important for you to understand the BGP table. So whenever there is two sections, status codes and origin code. I will explain origin code later. Let me explain the status codes to understand whether this network is learned from the eBGP or IBGP. Now I means it's internal, right? So whenever before your network, right, if it is mentioned I, it's mean IBGP internally done. If it is not mentioned anything over here, it's mean it's learned via the eBGP, right? This is how you can understand. Okay, hope you understand. Now next attribute is the originate locally. So what is as its name is very clearly mentioned, originate locally. If you configure any network within your router, that will be considered as the originate locally, right? And prefer the part that the originated locally, because if you configure any network within your own router, that will be considered that network as a originated locally, because you are originating the network locally, right, within your router. So this is one of the third attribute, I would say. Now I'm going to the fourth attribute, that is the AS path length, right? Now what is the AS path length? Let me explain again over here, right? So again, this is two router. Don't go with the drawing, right? Try to understand the concept, right? So suppose this is your destinations, right? This is your source. It could be your internet, right? The destinations. Now to reach this destination, you have to go through multiple A's, right? Multiple A's you are going through. Now another path you have to reach this destination or this internet router with the only one AS, right? One AS, and here is 1, 2, 3 and 4. Then only you reach your internet cloud. Or here this route, this path is takes only one. So this path will be preferable with this attribute. If your path is less, that route or that path would be preferable over here. So that's what the AS path length, right? If your path length is higher, that will not be preferable. If it is less, that will be preferable. And AS path length, well known and mandatory and transitive, right? But one thing is mentioned, that transitive within pair AS, right? So if you configure AS, right, it is transitive within your pair. This AS path length will go this router till it will not carry forward other router, because in this router that AS path can be manipulated. This AS path can be changed, right? So this AS path transitive but within pair AS. Hope it is informative, right? Now the fifth attribute is the origin code. Now it's very important, origin code. Now how this network is originated, that we have to understand. It's a well-known and mandatory, right? So where it is located, right? Origin, here it is located, well known, right? Everywhere it is known, and this attribute is mandatory. It should be there. You cannot avoid this thing, right? So this attribute sends you from where it is basically originated, right? So originated value is there, right? There is 3 protocol type is basically do use IGP, EGP, and the incomplete. So let me explain with the table only, so that you can understand better way. All right. So here let's understand. So this is the field of the origin code. Here you can see the IGP, EGP, and the incomplete. Now forget about this EGP protocol, right? It is not there, and next and onwards router you might not seen this thing, right? It's a legacy. So consider only IGP and the incomplete. So what is IGP? It's IGP protocol, but thing is that here any route learned or generated within the AS, that will be considered as a IGP. Like if any network you have learned and that network is generated locally with the network command, right? So you have configured BGP router BGP 100 with the AS number, then you advertising any network, suppose 1.1.1.0. so that network wherever it is generated within the AS number, that will be considered as a IGP, right? So where it is, here it is, right? So IGP, whenever I is mentioned after your network, right, in that particular row, it's mean this network is generated via the network command within the AS, within the BGP AS routing protocol, right? Now if it is incomplete, right, it's mean your BGP doesn't understand from where and how it's learned, from where it is originated. In that case it will show you as a question mark, right? So if you learn any network by the redistributed or by other protocol injected the network to your BGP network, in that case it will be show as a question mark. This network could be learned via OSPF, EIGRP or RIP and other protocol, or it could be learned via the redistribute connected command also, right? So if anything you are redistributing, that is not your BGP is understanding, in that case it will showcase as a question mark, right? Hope it is clear, right? So here whenever you learn any route with the IGP, that value would be 0, and if any value if any network you learn by the incomplete for like any other routing protocol like OSPF, IGRP or redistributed, in that case the value would be 2. Now lowest origin code preferable, so 0 would be preferable. Now if you learn a network or route that is from IGP, that will be preferable rather than incomplete, right? Hope you understand. The origin code is a 4 byte. It's you can ignore for this part. It's a 4 byte, like all these stuffs, this value, that value. Don't go with that. Just understand origin code is the code to understand from where it is generated. Where is his origin, right? Okay. So let's go to the next attribute, that is the MAID, multi-exit discriminator, right? This discriminator, or it's called as a matrix also, right? So what is MAID basically? It's an optional non-transitive but exchange between IBGP neighbor, right? Again, similar to local preference, right? So basically this made value, if you configure over here, it will be transitive within the AS, means it will work, it will transitive, it will travel via the IBGP domain, right? And the default made or metric value is 0, right? And it goes up to this value 4294 and 9675, right? And here, unlike local preference, higher is preferable, all these things is higher is preferred, like weight, local preference, all this stuff, but only mate is lower is preferable, like origin code, right? Hope you understand. Now let me take you to the origin code in the table, right? Sorry, origin code, it's matrix. It's my bad. So it's matrix made in sense, it's a matrix, right? The default is 0, it is showing because it's run by the IBGP only, and it is showing 0 because it's locally originated. That's what, right? Hope it is informative for you, right? So what is the next attribute after checking the image? It is the path type. What type of path it's learned, right? Now eBGP is preferred over IBGP. Let me explain over here within this slide only. All right, here is two router, this is your destination again, right? And now yeah, so this is your internet, is your destination, right? Now this destination route you have learned you can reach via two paths, right? One path is this, another path is this, right? Now this path you have learned via eBGP, right? Because this router, or router 2 rather, I can say router 3, router 2 is the your eBGP neighbor, and router 3 is your IBGP neighbor, right? Because it's comes under the same AS number, right? So this route would be preferable because eBGP would be preferable over IBGP. The same thing mentioned over here only. eBGP is preferred over IBGP. If you learn the same route from one eBGP, another one path is the IBGP, the eBGP will be preferable. It's very simple. Now the 8.1, right? That is the router ID, right? So what is the router ID? The lowest BGP neighbor router ID, right? So suppose again this is the destination. I will show you this stuff. This is the destination. So this router 1 and this is the router 3 supposed to, and this is router 2. This router ID is lowest 1.1.1.1. So this path would be preferable, lowest router ID, right? It will be preferable for the best path selections. So hope you understand. These are the almost 9 attribute you can say from the 0 to 8, right? Sorry. And this all attribute is used to tie break the BGP path selection mechanism. And this 8 or 9 attribute you can remember with a tricks I forgot. That is the we love oranges because oranges are made fresh food, something like that. So this attribute is very important. If you understand all this attribute, it would be enough for to understand all the attributes, right? The basic part, but the initial part you can understand. Now I will showcase you with the lab how this attribute being used to select the best path, right? So let me take you to this diagram, right? So before that, let me take you to the lab, right? So here it is. So try to understand this lab first, right? So the same thing I have captured, though I'm going to show you. This is the internet, right? Right hand side, right? And the source is over here, right? Just a minute. Yeah. So this is your source, and he wants to reach the internet. He have two path 1, another one is this is the another path, right? He can reach. Now we will check, right, how the path is looks like. Okay, as I show you, this is router 1. First I have to check whether we have the network. My router 1 learned this network 8.8 or not. So just a minute. So IP, well, the same command I have show you, right? So here what it is showing to you, let me, yeah, so it is showing that this network, to reach this network, you have two paths. One is the 2.3 that is there, another one is the 1.2 that is the below network, right? Hope you understand. To reach the destinations, there is two paths. One is the AS200, one is the another AS300, right? So AS path it is showing 300 and 400, again it is showing 200 and 400, right? Hope you understand. Now here try to understand the best path. How do I understand the best path, right? Here it is star mark or asterisk or then the greater than. If before your network there is this 2 sign, it's mean this is the best route and it will take this route to reach your destinations. Who is your destinations? This is the network. It will take either this path or this path, but according to the all attributes, following to the all match criteria, right? This path win, right? Why this path win? I will show you. But before that, understand this is the best path. How do I understand? First, that the asterisk mark or star mark, then the greater than sign. It's mean this is the best path. And another one is the star mark, right? Star means it's a valid, but it's not best. Now, one thing is very important, guys, over here. I don't know whether you have patience or not, but try to understand this part. If your router showing star mark, it's mean both the router in the RIB database, right? It is in the routing information database. But what about the FIB? If the best path only installed in the FIB, right? Only best path will be installed in the your forwarding database. You have two paths and both the path in your RIB, but only best path will be in the forwarding table. That's what this path will be followed to reach your destination. Let me show you. Yeah, this is your host. Now you want to reach 8.8.8.8, right? Just a minute. Suppose I have not run this just a minute. Yeah, so it is reachable, right? So I am able to reach because my network is learned via this network, right? So how do I understand this path is taken, right? This is the best path and this topic. Let me trace. Hope you understand, right? So it takes the path to reach, that is first it takes its own gateway. Let me explain over here. Please be with me. I will gain knowledge if you spend your time. Right, so this is your host. From here you are trying to reach the destinations. This is your gateway. First hop it is showing this, right? It's reached over there, then it's take 192.168.1.2, right? So who is 1.2? This guy, right? So who is 1.2? This guy. So we understand this is the best path it take to reach this guy, right? A destination. So 1.2 first it's take, then 3.4. Who is 3.4? This is the path, right? Hope you understand. So it's take the path, this path, to reach the destinations, right? Now how this path is elected? By following all the attribute. Let me explain this part over here, right? Okay guys, this is important section, right, where I will explain the tiebreaker rule, right. The same capture I took from here only and take the put the snip over here, right. So let's understand one by one. First is the next hop, right. So next hop is reachable, right. The second is the wait, right. Here is the wait. First it will check the wait attribute, right. So where is the wait attribute, whether I have configured wait or not. Let me check. For the both the router, wait is 000, so it's mean equal, right. There is equal, this is equal, that's what it will check the next attribute, right. Hope you are enjoying, right. So it is equal. Now it will check the local preference, right. Now how do we check the local preference? Where is the local preference, right? Under the local preference, nothing is there. I have not configured anything. Even default local preference is also not showing, because this route learned via the eBGP, right. That's what it's not, it's non-transitive within the eBGP pair, right. So local preference again equal, weight is equal. So what next? We have to understand the originated locally. So let's understand whether this network LAN originated locally or not, right. Is it originated locally? No, because if it is originated locally, in that case it will show over here 0000, right. For 10 network it's originated locally, but for destination this network it is not originated locally at all. It's learned from somewhere else. So it's again it's equal, right, for the both the path, for the 2.3 path and 1.2 path, right. Hope you understand. Now second is come the AS path length, very important. This is AS path length. Now understand the AS path length. What is the length? Where it will be mentioned? Under the path, right, here only, right. So path is equal, both the case 2 path, 2 AS 300 and 400, second path is the 200 400. So though both the path are equal, only 2 path is follow, again it's equal, right. Now what left? Origin code, right. So where we have learned whether this network learned from which type, right. Let's understand that also. Origin code, what is the origin code, man? Here, right. So both the network, sorry, this network learn for the both the path is origin code is I. So it's mean again it's equal, again it's tie. We are trying to break the tie, right. Hope you understand. What next? Made, right. Let's check the made, whether the made is configured or not, right. Where is the made? As I show you, right, in this column, right. So for this path, where is the made? Nothing is there, right. Again it's tie. I have not configured any made attribute. I have not manipulated the made, right. That's what it's 000. It's not 0. It's not reflecting anything, because I am learning from the different AS, right. Again in case of the made, it's tie. So to break the tie, we have to go to the next attribute, that is the path type, right. eBGP will be preferable over the IBGP. Let's check that part also, right. From where we are learning? Both the case we are learning from the eBGP. It's very simple. Nothing is mentioned over here. If it is learning via IBGP, it will state over there. So this network, to reach this network, there is 2 path, and both the path learn via eBGP. Again the same, we are in tie. So we are unable to break the tie, right. Still again here is try. So what left, right. Now the another option, the 8 number attribute is left, that is the router ID, right. So we are checking from the top, right, and going down one by one. Everywhere we face tie. That's what we are going one by one by another attributes to select the best path, right. Now what left? The last option or the 8th number is left, the router ID. Let me check that one also, right. So Where is the router ID? How do I understand? Here is the output. Still, let me take you to the lab only. Yeah, here it is, right? So we'll understand over here what is the router ID statement, right? So what it says to reach this network there is two path, right? Or rather there is two neighbor, right? So IP BGP neighbor, let me understand this detail, and let me understand another neighbor also. Here it is, right? So what we'll check over here, who having the lower router ID, right? This is the neighbor 2.3. What is the router ID? The 3.3.3.3, right? And what about next one is the neighbor is 1.2, and that router ID is 2.2.2. so who is the lower router ID, right? This one, this neighbor 1.2. so who own this match in type to break the tie? So who is the best? He is the best. Why he is the best? He having the lower router ID, right? How do we understand the best? There is two sign, asterisk and the star. Where is the valid and best path, right? So this part, this route, this path will be installed in your FIV, right? Forwarding information base, and these two network or those two path will be installed in your RIB, right? Hope you understand, right? So who own this match in last? It's very interesting. Who own this match? Router ID. The lowest router ID own the match, right? So this is how we basically check or to select the best route, or this is how BGP use all the attribute to check the best route. So these all 9 attribute you can memorize with one short term. There is oranges. We love all oranges, as oranges are made fresh fruit, something like that, right? So this is how this is a quick tricks through which you can memorize all these 9 attributes which is used to try break. So what we learn, all this attribute and how this attribute are being used to select the BGP best path, right? And what are the attribute to select, manipulate the traffic, weight, local preference, to manipulate the outbound traffic, right? And made an AS path used to manipulate the inbound traffic, right? Hope all are informative, right? We understand multiple things in this session, right? Yeah. So thanks for your time. I would say check this all this thing in your lab so that it would be more fun to learn. Yeah. Thanks for your time.